In this section, we continue with the basic information from studying software Insperia CAST, because when you want to simulation you have a different option when it's run, and you can see also when it's complete and when it's you need to run again, and when it's not complete, when it failed. But most of the time we have a problem in lost in third, because that is because when it's not floating complete in piece, and also when we have a problem with floating. But if you want to change, and also you need to change, because when it's not complete you can't see all information in Insperia CAST, and you need to run again. But before you start to run again you need to make a bigger gauge, or you need to change the speed. But it's better leaving same speed, but only change in design, change in gauge, and also you can change in temperature a little if it's not complete. But also you can see a result when it's floating, if it's close or no, to fill with all the aluminum. But if it's not close you need to make a little bigger gauge. But if it's so close, only change a little in temperature for floating, and you can continue and test again. And also we have a filling result, and we have all information for floating aluminum, for temperature, flow front, solid friction, vector, and the last year. But we have all information for floating aluminum. And here we have a solidification result, and also we have all information, description, option, and also we have a description, but I explain when we have a simulation. In this section I want to try first testing simulation in Insperia CAST, but first I want to have it some adjustment, and I want to show you some adjustment. First I want to have it here, because I make a split here, because when we fill it with metal it's better to have an angle here, because when you feel it metal go out. But I want to show you how to fix. You can see here in face I work with a face, and here you need to have it rotate face, and here ox or line, and you need to have it 6 for example angle, and you can see all face going 6. It's same in another face. We go with a 6. And I go with the extrude sketch, and I want to see it's I think it's a 25, because we can use here grade to fill it with a metal, with aluminum, or we can fix in Insperia CAST. But it's better we go in design here, and it's easier for us to create here. And we have it a runner system, and we have a gauge, and we have it also for refill material. Now we need to start for simulation, and we go and open Insperia CAST. Now we have open software Insperia CAST for make a simulation for piece. But I want to explain a little about Inspira, because it's Insperia CAST, it's for casting, it's good, and also it's not complicated for make a simulation. But here we need to bring files, it's here if we want, and we can have it in SolidWorks. We need to have a license for open in SolidWorks, but I have for in Parasolid. In Parasolid it's you can see also size. If you save it from SolidWorks in Parasolid, because it's not big like in step files, and we can open. And here it's to define material, which material we want to use for floating, and we have it here. We have aluminum, and we have it here different material, but I want to use a 44100 here. And here is temperature for casting aluminum, but it's for casting it's like a limit. It's better when you start from 670 and 780. It's between that temperature, it's good. but if we go in 740, but we go in Celsius because we have Kelvin. Now we have a temperature, and here it's a runner system, but we in design, when we create all, it's like it's a piece, but it's same if you have it split here, runner system. It's a gravity, and we want to have it in which way it's a metal floating. We go in X and we rotate 90 degree. We click with the right and say OK. Now we need to define a gauge. We have it here, and we go in gauge in middle. It's good, but if you go here, you can define and change which radius you want. But if you create in design how you want it, it's easier. Like we go only here. Now I need to have it mold. We go with a mold, and we need to have a temperature for mold and material for mold. But material for mold, we use that material. And temperature, it's optimal temperature, it's for mold from 200 to 350 for casting in this type. But we go in 280 Celsius. And here we need to say in top, it's here. Yeah, we started the mold. Now we are correct. We have a mold, and we have a gauge, and we have a part, casting part. Now I want to choose a speed for filling with the metal. And if I go in basic here, and I have its speed here, but we go 0.5 in speed. But be careful, sometimes you have it here. Maybe you have it in millimeter, or if you have it millimeter, when you go here, yeah, you can see, but you can change. We go in meter, and here, and filling time, it's that time. Now we need to start run. Now we start run, and we go in which we want. If you want only run for filling analysis, or we want to run an analysis for solidification, but when we have a shrink it and pour and everything. But if we say run, we can make a simulation in both one time both, but it takes a time. It depends the piece, how it piece, because how big and how it's complicated, because it takes time for a run all analysis. We have first a simulation, but it's not complete 100%, and we need to make some adjustment, because we can't cast it like that. But I want to show you a little for floating, how it's floating. You can see when it's floating, and we can change the speed here only for simulation, and you can see when it feel it. And in casting we see, because we have a problem for air here in this rib, in all rib, because it come in the metal first. I want to show, go back a little. When it's yeah, you can see in corner here we have a problem with floating, because it's stuck here inside. But one thing, it's good, because if we rotate, and you can see on this side, when it's floating, you can see all the air it's coming out, not to go with the aluminium and create a bubble inside. You can see air is coming out. But when we make a design, for mold, we need to think for rib here. We need to think in all rib. And also we need to think, because it's stuck air here in 4, and also in rib it's stuck air, and we need to think. We can see also for, yeah, you can see a little better for air when it's stuck. Yeah, speed it. Yeah, look, now it close, and if we don't have to go air out, we have problem with here in same, in 1, 3, 4 and 6. You can see for air how it's go air out. It's good, because if we have it direct, we have a problem with the bubble, but when it go in contact with a mold, it's better for floating, and we don't have a turbulence. And also when it's I want to show here when it start. Look, when it start, it's go down metal, because if we have it here, it's go direct in core, and when it's go direct in core, we have a problem. When we have it complete with a floating method and feel it, I'll complete the part, and I want to explain step by step for all, for a pour, a vector, and shrink it and everything. But now we need to make some adjustment, and we can simulation again, and we can see. But first we need to go and redesign and make some adjustment. But to make adjustment, we need to think to open more here, or we need to move this gauge down, because when we move gauge down, it's go faster, and we can have a test, and we can see it.